Okay, for all the DIYers out there, I wanted to give a walkthrough on the SPS system and how it works, some of the upgrades that we can get through some of the stretch goals. There's two sides to it, so I'll go through this side first and then just briefly mention what's on the other side. Okay, so all the connections you can read out here. I'm just going to go through them one by one. There's plus 9 volts, which is basically just the input signal. It's been power filtered, which we'll see the components on the other side. In means the in to the effect. The buff is for the buffer. There's no buffer actually designed into this. It's that if you design a circuit that has a buffered output, that allows the designer to take the buffer that's already existing in a circuit, design a specific one. If you switch it here when this is into buffered mode, when bypass happens, it takes the signal from this pin. So if you switch this switch into buffered and you turn the pedal off, that's the signal that you're going to get, and you as a designer get to control what goes there. This thing says -15. It'll eventually just say -V. That's the negative voltage. That can fluctuate, as you'll see later, depending on what kind of circuit you have in it. The ground, and then this is positive voltage from the charge pump. It says +15. I'll just label as +V later. And then we have the out from the effect. So this is the output of the effect. And then the LED pin here, you would have a resistor going to the LED to power it. There's actually some other kind of fun things we can do with this, which I will show you later with when I develop and update the blueprint delay, the yodeler, delay reverb, things that would benefit from trails. I've developed a way for you to be able to use true bypass, so there's not as the noise from the delay signals not constantly in there, but still enjoy trails, the natural decay. And basically the means by doing that is that when you press and to turn it off, to turn the delay off, you would press and hold the foot switch, and as long as you were holding it down, it would go into a buffered trails mode, and as soon as you let go, the signal would go into true bypass and the delays would be cut off. So it allows that sort of natural decay, but without all the extra noise and bits from keeping a delay or reverb basically in your circuit the whole time. Next is the foot switch, which in the other video I'll show you. Typically I don't actually wire this directly to the foot switch. I wire it to the board, which I'll create a template for to show you how I do that. And then the board goes with the foot switch. With the foot switch, all it needs to be is a momentary make and then break. So an ST on off, normally off. So when you turn it on, it connects. It's a momentary switch. One side goes to this pin and the other side goes to ground. So it's pretty simple there. This pin right now is basically the opposite status of the LED. So when the LED is on or goes high, this goes low, and when this goes low or goes off, this goes high. So I have potential other uses for this pin, but if you are someone who can program this is a microchip 8-bit microcontroller. If you have experience programming those, maybe message me and we can talk about what else we might be able to do with that. But that, as of right now, that's what that pin does. And then this is the oscillator pin. So it's connected to the 555 timer, and it has it's connected basically to the oscillator. What this allows is for you to actually take these charge pump voltages and actually increase them further with additional circuitry, which might be needed, say, if you wanted to make a why am I blanking on the word? Oh, phantom power for a microphone, like a condenser microphone, which doesn't take a lot of current but needs a great deal, even more voltage, so you'd be able to do that with some external components using that oscillator pin. So yeah, this is the oscillator for the charge pump circuit. This is a pre-programmed microcontroller for the relay switch, and there's some associated circuitry with that. And then over here we have the 5-volt regulator powering that whole section of the switch. From here, this is the side you actually see when you open up the back of the pedal. And so you can see where it says true and buffered bypass. And so there's a slide switch that you have access to as an end user that you can switch into buffered or true bypass. However, if you did not want to have a buffered output, it'd be quite easy to switch this into true and just clip that right off, so that no one accidentally switches it into buffered if you don't build in a buffer. So let me flip this over, and I'm going to quickly go through this side. Okay, so we've got our slimline jacks that fit into a 1590B2 enclosure, but you can pull them out and just wire any jacks that you want. All of this circuitry here, all of it right here, are capacitors, low ESR capacitors and Schottky diodes, all part of that massive charge pump circuit. This is the relay switch. It's non-latching, so when power is lost to the pedal, it automatically switches itself into bypass mode. We've got a massive capacitor here, 220 UF, to filter out any noise or ripple, and this isn't soldered in right here because this is actually a little too large. The one that I'm using I couldn't find when I was making this for the video, so I'll get that later. But this is an inductor, and this combined with the capacitor really reduces the AC ripple and any sort of noise on the power line. This is a over voltage Zener diode protection, and this is a reverse voltage Schottky diode, and so there's power protection built in along with all the charge pump and filtering and all that. Last thing I wanted to point out is if you did plan on using it with a battery, there actually is a way to do that here. So you can see that right here. There's a battery connection points, and the way it works basically is if you have a battery plugged in but then you plug in something externally, it defaults to the external. That's pretty typical, and then the battery's only on if the pedal is plugged in using standard instrument cables. But if you unplug the pedal from anything, it disconnects the battery, so you're not wasting battery life. Now, as part of some of the stretch goals, one of them is just gold-plated contacts, so that especially if you buy a bunch of these and you use them over the course of multiple years, they don't corrode over time and that kind of thing. You can stay in storage for a long time. Another one is to use some connect some MOSFET switches to this to lower the switching impedance. That will allow the charge pump to be able to push more current, which will make the voltages, will also actually increase the voltages on the same circuit by a little bit. There's a sort of upper bound just because the size capacitors that we can fit in here and the efficiency of that. So it's never going to be like plus or minus 18, but we can get it a little bit higher through just a few extra parts there. So that's one of the stretch goals. And then the other one is it's called the P3 system. It was developed and patented by DC Voltage a while ago, probably like more than 10 years ago. I know that. So basically what it does, this system, is it uses your 9-volt power on the actual ring of a TRS cable. So signal on the tip, power on the ring, and then you have ground. So you have one cable. You don't even need the power jack at all coming out. And the way that I've sort of configured things in my implementation is to make it simpler. The original implementation had a bunch of switches and all this kind of stuff, so made it a lot simpler. Basically, you don't need to do anything, and it senses whether or not it's safe to put 9 volts on that ring, and if it's safe, then it does it, and if it's not safe, it doesn't. So my power jack just fell out. So basically, if you plug in 9 volts into the power jack, it will send 9 volts to the ring if it's safe to do so. So if you plug in a standard TS cable shorting these two, it won't send that voltage. But if you plug in a TRS cable and there is no short between those two, it will send 9 volts and allow you to essentially have one power supply jack in and then have it power all the rest of your pedal board. So that's one of the stretch goals as well. I think I've covered the bases there. The rest of this video will just be a shorter section where I actually have it plugged in and showing you its usage in a pedal. I just wanted to show an early prototype connected in a pedal. This is a tractor beam phaser prototype. First thing I wanted to show you is this is a pedal that has a quad op amp and 2 dual amp op amps, and so on the charge pump here it'll read the lower voltage than some of the more standard pedals that might have just a quad or a dual op amp in it. They have less power requirements, so let me get that hooked up there. So negative 12.23 volts there, 14.96, so a little about negative 12 and 15, which is still a crazy amount of headroom out of a 9 volt power supply to put in a pedal, especially something this compact. You use a circuit with a quad op amp or just a dual op amp, you're actually going to see even an increase from that. And also, if we do get to that stretch goal to increase the output current of the charge pump, you'll see an improvement across the board as far as the headroom. But even as is, that is a lot. So a couple other things, like one improvement I already made is in the design. I noticed that the charge pump voltage was decreasing when the relay switch was on, because the relay switch takes current. And so I made a quick mod and added this capacitor, and it's already added to the next prototype. That made it so that basically the charge pump voltage remains unaffected whether the pedal is turned on and off. You can see I've used a ribbon cable here for a quick connect from here to the board below. I'll be giving out those specs so that you can design something yourself. And I did want to point out that the foot switch isn't wired directly into here, it's wired here, and then I have signal traces going up there. Yeah, that's it for now. Let me know if you have any questions. I'm trying to design this kind of be the ultimate thing for a DIYer to really make studio grade equipment in such a small, compact pedal board friendly format. All right, thanks for watching.